Hello everyone, I'm CY. Today I'd like to introduce a new multicast solution called BIERv6. Multicast is an important type of network service. Over the past 20 years, IETF has developed many multicast protocols that support multicast services forwarding. For example, it developed PIM, which we are already familiar with, ROS and MVPN, which emerged later, and P2MP, MPLS, MVPN, which applies to MPLS networks. These traditional multicast protocols share one characteristic: stateful multicast forwarding. To implement stateful multicast forwarding, a multicast distribution tree needs to be established, and each node needs to maintain the status of the tree in a multicast domain. In this way, the deployment, configuration, and the convergence of multicast services becomes more complicated. And then IETF proposed a new multicast technology, BIER. BIER introduced the concept of BitString. With the BitString, BIER allows stateless multicast forwarding to be performed in a multicast domain. A multicast domain contains ingress nodes, transit node, and egress nodes. In BIER, one bit in the BitString is allocated to each egress node to identify itself. For example, this figure shows 4 egress nodes, A, B, C, and D. Each of these nodes is allocated in 1 bit. Totally, there are 4 bits in this BitString. If a bit is set in BitString carried in a packet, the packet needs to be forwarded to the corresponding egress node. A bit index forwarding table, or BIFT for short, is maintained on transit nodes and other BIER nodes. According to the BIFT and the BitString, each transit node replicates and forwards packets and knows the destination egress nodes of the packets. RFC 8279 defines the fundamentals of BIER, and RFC 8296 defines the BIER MPLS encapsulation. That is how BIER is encapsulated on the data plane. Here is the encapsulation format. The packet has Ethernet header, which is followed by a label called BIER label. Through this label, a transit node knows which BIFT it should query. Next is the BIER header, which carries the bit string. As we just mentioned, the bit string identifies egress node information. The next part is an MPLS label that carries a VPN ID. The last part is the multicast payload. This is the MPLS BIER encapsulation format defined in RFC 8296. Such encapsulation is applicable to BIER forwarding in an MPLS domain. For IPv6 networks, BIERv6 was developed based on BIER forwarding and the encapsulation fundamentals. BIERv6 uses IPv6 scalability to embed all information required by BIER into an IPv6 header. Specifically, a BIER extension header called IPv6 DOH, which is short for Destination Options Header, is used to carry a non-MPLS BIER header. The bit string is carried in the BIER header. The destination address or DA field of IPv6 packet is a unicast IPv6 address specially allocated for BIERv6, and it is used to indicate a BIERv6 operation. The source address or IC field is an IPv6 address that carries a VPN ID. In this way, all BIER information can be embedded in the IPv6 header. So, what benefits does BIERv6 offer? First, because it implements BIER forwarding on IPv6 network and embeds all BIER information into native IPv6 packets. BIERv6 can use all existing IPv6 extension headers and functions, such as packet fragmentation and packet encryption, including IPsec. Second, because the DA field is a unicast IPv6 address, it allows services to be transmitted across the network, even if they traverse some non-BIER IPv6 nodes. This means that we do not need to abrogate the entire network if we want to use BIERv6, making its deployment much easier. Last but not least, because BIERv6 does not have MPLS labels similar to SRv6, interdomain deployment is simple. BIERv6 not only inherits the advantages of BIER, which is the BitString-based stateless forwarding, but also inherits the advantages of IPv6. These advantages lay a solid foundation for BIERv6 to carry more new multicast services. And this is the end of this video. Thank you for watching.